Hey everybody, I don't know who's there. Give me a second here while I set everything up. Screen share. All right, just waiting for people to come on in. We are live now. I will be having a presentation, live demos. All those are going to watch in this playback. Before I forget, if you have comments, concerns, questions, email me live at quantlabs@gmail.com. So hopefully people will be joining us. Yeah, while we wait, give it a couple of minutes.
I think in the past you needed a degree, but now it took.
Okay, I got 802. All right. All right, so 3 more minutes. Give me one more minute and I'll get started. I've already done this preview before, but I'll be getting this rolling in about 2 minutes. Hello to all. We're just waiting for more people to come in. I'm expecting not a whole lot. We don't get as many numbers as we usually do via GoToMeeting. Okay, so just making sure that if you got comments or questions, just email me for interactive, because it's a one-way at this email right here, quantlabs.net. Let me know if you can hear me and all that. If my audio's good, because I don't know. I've done a test at my end. Everything seems to be cool. All right. Give me a yay or nay at quantlabsnet@gmail.com. Let me know if you can hear me okay. Okay. So, in case I cannot be heard. All right, so let me just get started here. What we're going to do is, I've done this video before in a half hour, but I'm going to condense it right down. The whole idea of this video is to take any questions that people may have. I am making a lot of progress on my algos. I'm about halfway done already. When I say rapid development with this methodology, it lives up to its reputation. I'm quite impressed with it. I've worked with a lot of environments and languages and stuff, but nothing like this, what I'm about to show. It's very, very effective. And you can have a whole complete system running usually within a few days. The way I'm going. Highly encourage anyone to do it. All right, so we are at 8:06. I'm just doing one verification on something to make sure that we are able to see myself online. Give me a second here. I'm just verifying. You might even get some feedback. Wow. I'm one day going to be off of Windows. I'll be partying in the streets. Ugh. Well, it don't matter. Okay, forget that. I'm assuming there's people out there. All right, so let's get started right now. All right, so the big challenge a lot of people are coming across from my research, the top three are usually what I call research programming languages, this be it Python, R, and MATLAB. Each one's different. Each one has pros and cons. The ones that I've seen, obviously MATLAB's my favorite, so I spend a lot of time with it. Of course, we can always have the difference between time versus expense of open source. What I mean by that, get that in a minute. And then the other big thing, a lot of people that do research their own trading ideas, a lot of errors. All right, so let's get into the researching of programming languages. Languages like Python or R are not future-proof. What I mean by that is just let's say in Python, the world of 3.3 versus 2.7, a lot of the major packages like pandas might not be up to date in 3.3, so a lot of people are stuck in version 2.7. So a lot of the major packages don't get up to date. Same with R. Any package that you use might not be compatible with your core version of R or Python. So again, that comes back to what I'm just mentioning here, out of sync from packages. Also, depending upon certain packages, you need to ask yourself the quality of the mathematical results you get from them. And the big one, from the reading I've already taken from the Python algorithmic trading book from QuantStart, he mentions a lot of algorithms and scripts are really slow. And there seems to be this major focus on parallelizing and clustering, which can cost big dollars. Then the other thing is, once you get a trading algorithm complete or strategy, how do you integrate it with C++? And when you do that, it can be limited or really complicated. A good example that I've spent a good amount of time on is RCPP for R, merging the technology of bridging the two between R and C++. I think it only works with Linux and Mac. It doesn't work with Windows. Also, the second big problem a lot of people have is time versus expense for open source. Of course, you need to consider, because you're using a language that might be free, you might be spending a lot more time than you need to in that language because it's free. You need to factor your time is still valuable. I still believe in a do-it-yourself approach. I've run into programmers or human traders, will leave it that have hired countless number of programmers to implement a strategy, and it only needs to know whether, I think they're on their 50th programmer or something, and they spent like a couple $100,000 and still nowhere. So it's a big thing you need to take into consideration. Also, when I say smart commercial software can get the job done, yeah, it'll cost you up front, but usually you need to consider, as I said, the open-ended, unlimited issues that you get with third-party software developers. You know, usually they're not meeting your expectations, and you're spending a lot of time, and essentially these 2 points, you're held hostage to what these programmers or your developing team are capable of. Not a cool thing, obviously. The other big thing you need to consider, and this is a big one that's never talked about, is being error prone. Give an example. You get Dr. Ernie Chan. He'll develop a trading strategy in MATLAB, let's say, and then his end target trading system is done in .NET, C#. So his partner, they spent countless of probably weeks testing the .NET version to make sure that the exact results that he expects in MATLAB are the same in this trading system done in .NET. That can take a lot of time. And the question is, as a human trader, most of the time, are you professional enough to do this? And if you're relying on development teams, do you have confidence in what they're capable of doing? Before I continue, anybody new, got questions or comments, just email me here at quantlabs.net. We'll just rearrange here this slide. Give me a second here. Alrighty. Okay. Let me just check my email, see if anyone can see. Nothing new has come in, but if you have any comments or questions, just email me here. As I said, quantlabsnet@gmail.com. Okay, so we've talked about the top 3 current issues a lot of trading researchers go through. It's going to be quant researchers as well, and the professionals go through it. Again, researching programming language considerations, time versus expense of open source, and big one, never factored in, is Errorprone. Okay, so I've been working on my workflow for what I call best workflow to HFT. I've spent a lot of time. This is using MATLAB and all the components and tools that come in MATLAB, and then that's why I talk here, smart commercial software, what MATLAB is. And I'm going to show you exactly why I think that is the case. All right, so knowing all that, let's talk about this. This is what we're trying to do, and this is based on my own experience. Big one is you want to verify your mathematical expressions exactly from wherever your resource is coming in from. So if it's from a research paper, a book, or other source, you need to make sure it's exactly. And there's a lot of interpretation if you're using Python or R, especially if you're a newbie to it. The other thing you need to consider is you want to rapidly translate your idea most likely to one of the fastest programming languages out there, which is usually, which is without doubt C or C++. The other thing is you want to hopefully visually develop your trading idea with enough power and flexibility with no restrictions. Good example of that is, let's say if you use the cloud solutions like Quantopian, you're really limited on what you can do through their API and the capabilities of it. Also, if you are using a cloud solution, you will be very limited on the type of assets they can trade, be it with Quantopian. I think it's just ETFs and stocks for US. So you're really, really limited there. And then the other thing is, let's say if you want to go high frequency trading, and I've seen a lot of different ways to deploy high frequency trading systems. Obviously going to be done through software, but ultimately, for those that want the ultra lowest latency, if you want that environment, basically FPGA is your solution using high frequency trading. So I'm going to show you some live demos in a minute. I just got an email from somebody here, Eddie, asked PMML. Do you think PMML can be used to overcome the problem of model translation of C++? Eddie, I don't even know what PMML is. If you can email me a link, I'll explore that in a minute, and let me know what you think from your end. I'm just showing you what I do. I'm not sure if it's a open source solution. Okay, so let's take a peek. And somebody asked about, Ron asked about undocumented MATLAB, which is from Year Altman, I believe. It's a good solution, Ron. Again, though, that is more for lower frequency. If you're trying to trade out of like interactive brokers right within MATLAB, nothing wrong with it. It's actually one of the cheaper solutions that I've seen, but again, you're bound to MATLAB itself, so that's going to be kind of limiting. And I've seen some of the books as well, but I haven't really delved too much into them. But this, I think, is the better solution to go with C++, just due to the fact of some of the performance that you get with C++ and the less the efficiency of the memory as well with C++ as well. The new, I should say new, the version 14 that just came out, the spec for C++, makes life a lot easier. We don't have to worry about cleaning up your, or it'll automatically clean up your code when you're doing a lot of pointers and that sort of thing. So that's kind of now built into C++, so it's getting a lot easier to work with on the memory side as well. So I really like this solution. So let me just see if anyone else has come back with it. Nope, not yet. Okay, just give me a second here. Appreciate you guys hanging out as we are hanging out on YouTube, no pun intended. Okay, so let me show you the first point here. Now remember, I'm talking about verified mathematical expressions exactly from your research paper. Okay, so I'm going to show you an example. I'm going to hop into my MATLAB. Now this version I'm going to show you is MATLAB 2015. This is the current version. Just came out in the spring. There's a editor in MATLAB called MuPad. Now, basically, there's some very, very cool things you can do with MuPad. So give me a second here while I change my directories and show you a more complex example of showing you exactly how you can get the exact same results. All right, so what I'm going to do is I'm going to load in this file here. Okay, so let's just say you see in a research paper this expression, and then you also see this. Well, when you use MuPad here in the red and you enter in the MuPad language, it will tell you exactly and give you the exact scientific notation, so you can verify that against your source. So you can get that exactly what you would expect. So in this case, if you solve, this is what it will output, and you can verify that in your research paper or book or whatever. It's a very, very powerful feature, and it enables you to have full access to all the different abilities, sign. You can build expressions as such in MuPad. Okay, just want to show you this capability. What you get back in blue is really important. That will reduce the amount of errors that you would get when you're translating from a research paper or a book or talking to somebody. And then it ensures that you get exactly what you're looking for. Now, I've never seen anything like this. I mean, I know there's IPython, but I don't think it has this capability at all. I know there's LaTeX as well, but that's a lot more complex to set up. And it's really more, LaTeX is more of a translator for reporting. This is really meant for designing algorithms. And what you can do here is you can go into the command window of MATLAB, and you can translate this MuPad file into an actual MATLAB function that you can then drop into what I'm about to show you, an environment called Simulink. It's very powerful. Let me just check to see if there's any other questions. Hang on here. Okay, anybody have any questions so far? If you're new, I'm taking live questions right now, quantlabs.net@gmail.com. Eddie, I wish I could address your PMML. I've heard of it. I've never played with it. I'll take a look at it after my presentation. We'll give a chat about it. And I'm thinking I kind of know what it is, but I can't really comment because I never used it. But again, with MATLAB, I've not yet run into any bugs whatsoever or any hindrances from me using it. It's just very powerful. So let me go back to my presentation here. So what I just showed you with the mu pad is exactly as I said. You have your mathematical expression, and that you can now verify it exactly from your source. Okay, so it's really, really important. Now the other thing is, let me just show you adjust this one in the next demo. Okay, Eddie's got another question. What do you think of predict? Okay, so let's address that in a minute, Eddie. Let me just finish this slide, and we'll talk about it. Okay, and so as I said, visually, a lot of people that might not be strong in programming want to build out their ideas visually. So MATLAB has this environment called Simulink. So if you come into the command line, just type in Simulink, it'll load up Simulink itself. So in my case, I've already got this preloaded up. This is a model that I've been playing with. I have this on my YouTube channel. So basically what I have here is we have blocks. Let me just show you examples here. So if you bring up this thing called the library browser, there's hundreds of blocks within MATLAB. There's some third-party ones. This is all based upon electrical engineering when you're designing schematics. So it's the same idea, but you can apply it to finance, and it's very powerful. So this is all new. These particular ones for in the new 2015A, get some gauges and some knobs, as you can see here in this particular model. So let me show you how this works. Each block has a constant. So in my case, I've set one for a CAC. This is for futures trading. I'm going to be calculating the basis, which is my first algorithm that's going to be part of my futures and options trading system. It's a very primitive system that I'm showing you right now. But in this case, I have this constant, and I can alter this with the knobs, and I'll show you that in a minute. I have another one for the future price as well, a block for that. And these are variable depending upon how I interface with these knobs. And then here, this is where it's really important. With the mu pad that I just showed you, you can take that mu pad, once you create a MATLAB function, you can then take your algorithm and deploy it right into your Simulink model like this. And then you can have your inputs, in this case, the cash price, FC, future price into FP. And these are your arguments, FC, FP, and then you have your output called basis, and it does a little calculation. This can be very, very sophisticated, obviously, but I'm just keeping it really simple and kind of dumb, easy for demonstration purposes. And then it'll output a basis. So here's the output. We can create little truth tables, sort of like a if-else statement within Simulink. It gets more sophisticated when you start using state flow charts and blah, blah, blah. And then you can have finally a scope, which is kind of like a output of, in this case, I'm just doing a trading decision if it's -1 or 1, buy, sell, like kind of like an oscillator. So let me I've got my cash price set at 102. I've got my future price set at 99. Now, as you can see, the differences between the cash price and the future price, it's going to output the difference. And that's what we can expect in that gauge, which is this guy right here. So if I run the simulation, which I believe it's running right now, so if I move my output to 103, move forward, you can see that my gauge is now moved, shows a difference of 3.93, and you can see that this gauge gets updated. Now, you can build some very, very sophisticated models with this, like really sophisticated. I've gotten verification that Goldman Sachs is using this. Goldman Sachs is using this. A lot of the big banks use Simulink to build out their systems, their trading models. Now, why are they doing it, and where does the high frequency trading come in? Well, let me show you. Let's address the next section. So we've got our model here, the visual representation. That's the key. So if you're not strong in programming, you can still build out this model visually with all the blocks that I've shown you, right? So now let's get into the high frequency trading part. Two things. There's actually 4 options you can get with Simulink. I mean, these are all toolbox of options that you pay for as you need them. First, I can generate code from that Simulink model. I can either generate C or C++. Okay, so that can be deployed into an actual trading system or put it into some kind of library of algorithms. Secondly, if I choose to go ultra lowest latency via, let's say, using FPGA boards, again, this is where the guys or gals, will leave it that, at places like Goldman and other banks use this option for their high frequency trading deployment. You can generate HDL, which is a proprietary languages for FPGA. I'll show you what I mean. Going back to my model, this is what no other language, no other platform, no other system on the planet does this. So we built out this model, the visual representation of it. So now if I come under code, I can now generate C or C++ code. So I stop my simulation. I come under here, code generation options. This is very powerful. Remember I said you can now save time and instantly develop your code? Well, you can now generate this code. You have targets. You can set different hardware settings through these different targets, and there's dozens upon dozens of them. This is just a generic one that I'm using. I can choose my language, C or C++. I can also choose my compiler that MATLAB will have access to, so I could use, in this case, the Visual C++ compiler. If I'm running Linux or Mac, I could choose the GCC. If I am using a more higher performant compiler, I could use the Intel compiler. No problem. I just change my settings here, and that's it. You don't have to go into weird configurations and just basically configuration hell to get things done. All right. So all you have to do from there is just build. Okay. Now I'm not going to build anything, but I'll show you some what it will build. Just give me a second here. So in this case, if you come under here, it will generate a set of code. So here, you'll get your C++, your header files, even a make file, and all the components that come with it. I'm not going to get into this, but I just want to show you that this can be done, okay? As well as C as well. Now, hang on, give me a second here. I do have a GitHub repository. Oh, just give me a second here while I load that up. If you want to see the source code in the actual projects what I'm showing today, you can actually do that. If you come under here, and there, maybe this might work. Okay, so if you come under GitHub, under my Quant Labs, if you come under the repository, this right here I just created a few days ago. This is the demo code that I just showed you on the actual source code with all the resources, the MATLAB file, the Simulink files, there's an exe file of what's generated, and the actual C, C++, all that stuff. You can go into this repository and play around with it and poke around, see what kind of code it generates. It's really good. Any questions so far on this particular process? Okay. Hang on, Eddie. We'll get into the PMML in a minute. Now, I've also talked about ultra lowest latency. It is fact, if you're doing the hardware solution, FPGA is the way to go for hardware custom building. So again, This you will not get anywhere else. Not like this. You come under code again, you choose HDL, hardware description language, under options. If you want to choose this methodology for FPGA, which is ultra lowest latency again, there's two languages you can choose from, VHDL or Verilog, okay? Each of these are the proprietary languages that are used for the boards that are from Xilinx or Altera, okay? I'm not an expert in this. I've not done any of this stuff, and I don't dare to until I bring in some more experienced people that can show me this. But with the new MATLAB 2015, they've now got a complete end-to-end solution to be able to deliver this type of code and burn it and synthesize it onto a FPGA board from this model, visual model representation. Okay, I want people to take that away. That is very, 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 very powerful. Okay, so again, there's nothing out there that does this. That's why I say this is probably the best workflow you'll get anywhere if you choose to use to target hardware or go high frequency trading. Okay, so let's continue on with our discussion here. So I'm showing you how to get even to ultra low latency with the FPGA. Now, the other big thing is, where do you house the data? You know, we're talking about news feed data, so on and so forth. I am looking at a possible, I've been investigating it, researching it, a NoSQL database called Redis, and with the new version 3, which now includes clustering and failover. I've seen some demos on YouTube. It's unbelievable. It's unbelievable what it can do. Obviously, when I say NoSQL, it's free and it's simple, and it's in a memory data store. It's true open source. It's written in C, and virtually there's no limitations on number of instances. So if you decided to go on Amazon as a cloud solution, you'll be paying for the instances that you create. If you run it locally, it's virtually, as I like to say, infinity, or scale it to infinity, literally. It's very easy to maintain Redis. And one of the companies that sponsors Redis, they claim, and I believe that it is the fastest database on the planet. Now here is the claim that really blows my mind, is that Redis claims that you can get 1.5 million operations per second. I mean, I've seen Oracle, the highest they claim is maybe half that. Same with SQL Server, but these guys are 2.5 times. The other powerful thing with Redis is that you can use an embedded scripting using Lua right in the Redis server. So I am looking at this, and the real turn on for me is the clustering versus the clustering and the failover. Very powerful. And again, because I have the capabilities of generating all my algorithms now in C, I can easily integrate that with Redis and have a complete end-to-end system in C or C++, my choosing. All right, so that's Redis. Okay, so let's talk about our algos, what we're looking at. Hopefully you've been following me. There's the UC, University of California, I believe, Davis, has an options and futures course. And it's a fundamental view of looking at real-time supply and demand of assets. A lot of signals can be generated from these, and you can easily apply high-frequency trading techniques to these. Lots of people have been asking about the arbitrage opportunities that can exist in these signals, market conditions. I'm actually not implementing it, but I'm actually preparing them for MATLAB as MATLAB functions, and over time I'll be deploying those algorithms into these things, these Simulink models. Obviously, I can have better simulation control using these little knobs and output of gauges and stuff like that. Pretty powerful stuff. Okay, so that's where I'm at. Now, the other big surprise I haven't talked about yet is futures of Forex trading. I'm waiting on a new course to get my hands on, probably not till the fall. I'll be implementing that again into the Simulink and building out various systems, one for futures and options, as well as one for Forex as well. So I am obviously taking that into consideration. Okay, now let's talk about the HFT training system I've got for, I just put up the source code. So I'm going to talk about very high level on what it does. First, it will go out and gather data sources to identify profitable market sectors. Right now, the big focus is on US and European countries. The second step, what it'll do is it'll scan markets to identify long and short arbitrage opportunities used in stocks, ETFs, mutual funds, and indices. I talked about these two steps in separate webinars. We've got one person that's been probably eyeing this. My focus right now is on ETFs because they're safe, less volatile, but you can roll it out to any of these asset classes. On top of that, now I have my access to IQ feed. Literally, it can be universal, and I'll be turning on my Interactive Brokers account as well, which will give me better data in an unlimited way. Futures, ETFs, stock, blah, blah, blah. It goes on and on. So let's talk about the third step. Now, what will happen is because we're generating ideas of long and short arbitrage opportunities, these go through a qualification process, and once it passes that qualification, it'll add the long and short pairs to an automated watch list. So basically what will happen is that automated watch list will get monitored. The system will then basically look for any entries using the long short pairs. It'll automatically set soft targets of stop losses for exits. So there's various techniques I'm using like ATR, beta, trend lines, as well as moving averages and whatnot. So I'm looking at that as well. And once this system, as a last step, will maintain those open positions, they'll look for optimal exit profit potential. And all in that whole process, they'll obviously have to maintain the account, be self-adapting using risk management like Criterion, and obviously to ensure trading capital is preserved, which is really, I keep stressing, that's your number one goal, is to preserve your trading account, not make money. All right, so let's take some further questions. I know we've already taken one from Eddie. Just give me a second here while I load it up. All right. So Eddie's asking, I'll just put this into an editor here. Okay, so if you have any questions, just email me at quantlabsnet@gmail.com. Taking those questions, no problem. And let me just load up Eddie's question here. Okay, so this is what he was talking about. Hopefully he's online here. So in R, you can use PML package to convert your model to standard-based PMML format. Then the model can be executed using a PML execution engine that are such for most kind of production target systems, since many modeling tools, including R, SAS, SPSS, has a PML explorer. You can deploy your model into production in minutes. Example code. I guess it looks good, but into an PML execution engine. The question is, let's just do a search on this. Here. Let's see if there's any. Oh, I see. So let's just load up my Google here. It looks like there's an integration into Hadoop. Okay, so here's my result of. The question is there any C integration? Does it co-generate to native C like what I've shown in my demo, because that's what I'm after. Not sure if it's if it's a comparable, a valid comparison. That's all I'm saying, Eddie. Okay, hopefully that will answer that, hopefully. Can you expand about back testing done on your ETF strategy? Okay, so that'll bring me to, that's from Ron. All right, so Ron, okay, so as you know, the ETF that I'm mentioning here, this system is not really needing to do any real back testing because it's basically it's looking for opportunities. So there's no solid. I mean, there is back testing, but it's just to compare the selection of the long and short pair if they are at the max in their spread and the difference there. So if that's the case, then the only thing I can really test is if the stock selection is valid. I still need to go through that as part of that series. It's the only thing I can probably back test. ETFs is a little hard to do because you can short ETFs, but you might get better spreads and better differentials if you're going to focus on stock for this type of system. ETFs is really used for just this step and for market scans to see what kind of sectors you want to focus on, and that's where the ETF or mutual fund or indices selection comes out of. But if you're trying to use it for long and short arbitrage, really it's most effective on stocks itself. But you can still kind of use the first step and the market scan for ETF for as I said, the stock sector, as I've done before in one of my webinars. I think you were part of those. And then that's where the ETF analysis would stop. But the short and long for stocks would continue through steps 3 to 5. I don't think it'd be as effective for any of these other asset classes. Just stock, it's all we really work for. So hopefully I'm hoping that can answer your question. Let me know if you have any further questions. That's pretty well my demo tonight, this workflow. But like I said, the big advantage is this generation of code for C, C++, and HDL for FPGA. So let me try to address the PMML to C++, let's say. Down here. Let's see here. So if I do PMML to C++, let's see if there's such an animal. Okay, Stack Overflow. Like I said, I've seen this before. Let's see what it says. Yeah, it's pretty complicated to be able to get. You see here, there's this JVMML through Java. It's a pretty lengthy process versus this type of process. You got your visual model options, and just push a button. That's it. Here, I think you're going to go through a hornet's nest process. If you got to go through this JMML or whatnot. And again, that comes back to exactly what I talked about. Two factors you need to consider, Eddie. Your expense of the time, and this is an open source option. So are you willing to go through those extra steps to get the job done versus, as I said, if you just push a button to generate C++ code or C code or HDL code from right within the simulated settings of your model. And again, Errorprone as well. Is it highly qualified versus what's coming out of MathWorks? Any of these products are high quality. They have engineers to ensure quality of the code that it generates to make sure it's efficient as well. So that's what you're really, really paying for. So that reduces your errors. So those are factors you definitely need to consider. Anybody else got any questions? Again, here's an email, quantlabsnet@gmail.com. Let me just check something. Okay, so if there's no further questions or comments, we can talk about anything you want. But I just wanted to show this workflow that I'm focusing on, and believe me, it's working out really awesome. This took me, to be honest, to figure out the gauges and knobs. It took me no more than an hour from no documentation. For instance, to integrate these knobs is very easy. You just highlight this, you'll get this little guy light up, connect, and you're done. You got yourself a working knob that's integrated from the constant into the algorithm. Same with the gauge, because I've connected it into the MATLAB function. You know, you can do some pretty crazy stuff with this. Very easy to work with, very intuitive. And we just got another question. So Eddie, the idea of PML is there's no need to translate to C++. Your is special that generates C++, in which case you don't need C++. Yeah, exactly. So let me just so people can see this. This is from Eddie. The idea of PMML is there no need to translate to C++. Yours is a special is that generates C++ code, in which case you don't need C++. Yeah, exactly. But as I said, my target is to go for high-speed trading. So if I wanted to generate C++, because it's the fastest, pretty well programming language out there, which is pretty well the standard. Everyone is trying to, I would say all roads lead to C or C++, no matter if you're using R or Python. And why do I say that? Well, all those languages are written, but in both of them are written in C. So, you know, use the native. And again, I'm using this purely as close to get as I can get to high frequency trading in a convenient way using this. But it sounds like the use case with PMML is different from my target use case. So hopefully I'll help you out. I think this is useful, but for my needs it's totally different. If I was to run an analytical system, it makes sense, but speed is of the essence. So again, I need to write, hopefully the code generation process will give me tight C code. That's what I'm saying, efficient. Anybody else got any questions? Because I'm only doing these kind of sessions at one time. And all my algorithms will be built around this. So even if you can't afford C++, or sorry, you can't afford MATLAB, and if you became a member of what I have, the cool thing about it is, let me show you this. So in my case, if you became a member, you get all these files. So in this case, you get the Simulink file, this SLX file, give you the MATLAB custom file, M function. So even if you don't have MATLAB, these would be kind of useless, but where it would be very useful is the actual C code that I generate. So you would have access to that. So you could still be able to generate and work with the algorithms that I use in my own future trading. So let me give you an example of some of the comments, because that's one of the other big advantages with this code. The comments are very powerful, so you can see exactly what each step is doing, and I'm ensuring that people understand that. Of course, I'll include walkthroughs of this as well. So that's how I'm going to deploy, even if you can't afford the MATLAB as part of as an option. Another question just came in, Eddie. The tool you're using typically used in hardware development is interesting that you. Yeah, here, let me get this question for people. Again, this is from Eddie. Thanks for all the questions, Eddie. Keep them coming. Same with you, Ron. Okay, so let's see what we got here. We just got questions. email me here. So let's address Eddie's latest. So what you're using is typically used in hardware development. This is true for HDL. It's interesting you're using this to develop models. FPGA is a hardware component. That's true. I'd like to have an opportunity to talk to you about quant, like you develop and deploy models. If you have Simulink, we can do this another time. No problem, Eddie. If you want to get in touch with me, I'm not sure if you use Facebook. Let me just load up my Facebook here. A good way to, well, actually, there's two ways to get in touch with me. Let me just load up my Facebook, just so you know what I got on Facebook. If you come under my Facebook here, I have a group. Yes, I have a group. We just launched about a year ago, so you can reach out to me on that. Become my friend on Facebook, and we can chat that way. That's a very active group. We're at just over 2,000 members now, approaching 2,200. It's one way. I don't know if you use Twitter, Quant Labs. You can actually email me here if you want, quantlabs.net. So there's different ways, and you can just reach out to me via Meetup. Anybody else got any questions? I can help you out wherever you need, Eddie as well. Same with you, Ron, and anyone else. Got questions, let me know at quantlabsnet@gmail.com. Anybody got any further questions? Just under an hour. I want to show you something to show you how the big banks are using this stuff for their high-frequency trading. I want to show you a PDF. I'm just trying to find it if I can find it. No, I can't find it. Okay, there's a YouTube video, and let me just see if I can find this on my blog. I'll show you this PDF that's out there. This is just a showcase because people think this is all smoke and mirrors. I can't. Well, here I'll give you the video. There's a video that I have, which basically will showcase that MATLAB or MathWorks helps implement these kind of solutions into environments like State Street, Goldman Sachs, JP Morgan, a lot of companies. And this is purely for high frequency trading. This is just one option. What I just shown with the Simulink. There's a lot of uses out here, but they don't really talk about it a whole lot. Anybody else got any questions? If not, we could give her a wrap, I guess. If you have a question or a concern or whatnot, here, reach me at quantlabsnet@gmail.com. Anybody at all. Hopefully, this is helpful for you. Like I said, I'm planning to deploy all my future models into these Simulink models, generate code from them, and build out static libraries. And again, because it's C and C++, can be pretty well deployed onto any environment. I'll be focusing more on Linux. Just life is much easier on Linux, I find now. It's much more advanced. And I have a running version of MATLAB 2015 on Linux, Ubuntu specifically. The Ubuntu's come a long ways to make life a lot easier for people. A few years ago, it was not possible. Same with the Interactive Brokers TWS Trader Workstation as well. So I'm hoping to deploy as much as I can off of Windows and on Linux. And the other thing is, I haven't really talked about this a whole lot. In MATLAB for front ends is MATLAB guide, so I will be able to generate user interfaces. Basically, generate some really good user interfaces with MATLAB, what we call MATLAB guide, and then be able to deploy those in a Java jar file, and then create some client code to create executable jar files, so that you'd be able to run my front ends to this interface on the back end with the database and the Redis as well, all connected up, and all the charting and stuff. And that is probably how I'm planning to deploy everything and pull it all together. It's gonna be very cool. I'm very excited to get that done once I get past my algorithms. And so far, I'm having some pretty good success with it. Anybody else got any questions? Anybody new? Thank you very much for joining us. We are taking questions. quantlabsnet@gmail.com. We have had a bump in viewers. Thank you very much for joining. If you got anything you want to talk about, I've talked about the Simulink model, live generating C++, C, and HDL code for FPGA, which is obviously ultra lowest latency. I do have a copy of my slide deck if you missed my presentation, this guy right here. Let me show you some video playlists I put on my YouTube channel to make life more interesting. Okay, so if you come under my YouTube channel, quantlabs.net, and adding some new channels, which are basically video playlists. So if you come under channels, oh no, playlists, I'm sorry. Oh no, wrong one. Yeah, wrong browser. I got two different Gmail accounts running right now. Let me get to my YouTube channel, my Quant Labs. That would help. Here we go. Okay, so here we are. So if you come under playlists, what I've got here, I've added 3 channels. This one is this topic, what we're talking about, your best workflow to HFT. Okay, so here I've added various videos that are on this exact topic, which I'll include the playback in this playlist. And I've got a couple half-hour videos here, but this one is the one that I just put up, and that's a half an hour using the exact process and just showing you what I just showed you. There is on my YouTube channel, give me a second here. I'm just trying to find a document here. Hopefully it's live. Let me just pull it up. Okay, so I've got an FAQ section on my website. I've got a knowledge base. Come under here in the questions. Come under technology, or specifically, I've also got one exclusively for MATLAB and Simulink. There's various questions on here. So here's the 30-minute video, this one right here, which has a lot of interesting things in it. It has the video in there. Come to this link here. Yeah, here. There you go. Okay, so this is a 30-minute video I'm talking about. Also, I've got the presentation I just put up here. This slide deck you can download here. And as I said, I also have my GitHub of all the source code as well. So all of the information I've given you is here in one spot. So what am I talking about? Here's a half-an-hour video I made on Sunday. This is the introductory video on this, how this workflow works. It's another half-hour video. And in this, I talk about my different playlists I'm just introducing you to. But specifically, if you're interested in Redis, there's this video on the 1.5 million operations per second from Redis Labs. On top of that, this is the course that I've been studying on the futures and options. This is easily the best that I've seen of anything for futures and options. And there's a playlist here you can get access to. So lots of goodness there. And yeah, there's also the GitHub as well. But as I said, if you go to GitHub, github.com Quant Labs. Yeah, Quant Labs. Yeah. My typing is atrocious, full of fat fingers. So if you come under repositories, choose this project, Simulink 2015 to C++, you'll get all the files I just showed you, all the samples, all here. See, the C files are here. So you can get access to it all and play around and see what it generates. And if you got MATLAB with Simulink, you can do some really cool things and just see how it works. Alrighty. And then I got this one as well with the knobs and the gauges, which is kind of cool. It makes life a lot interesting when you have these type of visual representation. Let me check. Okay, so again, it's going to be blabbing all night. quantlabsnet@gmail.com if you got any questions. Let me just check it. Maybe it has come in. No questions so far. It's got a couple of viewers. Thanks again. Hopefully, this is really helpful for anybody that's interested in going down this path for high-speed trading. As I said, I'm able to, without a doubt, bang out models very quickly now. About halfway through my algorithms for this, from the course I just showed you. The where is it? I have so many windows open, it's confusing. Yeah, on that UC Davis course I just showed you on the futures and options. So that's coming together quite nicely. So again, if you got any questions, comments, whatever, hate mail, send it away at quantlabsnet@gmail.com. Let's see if there's anything new that's come in. I don't think there is. If nothing further, it's been an hour since I've been blabbing, talking to myself. But thanks for all the input and stuff. I appreciate it. If there's nothing further, we'll call it a night. And I'll have this playlist up on the playlist I just showed you. On see, I'm very confused here. All these browser sessions open. Yeah, so I'll put it in this playlist here, the best workflow to HFT. So this video will be added to this playlist as a live component for all your Q&A. Anybody else got any questions, comments? I'll do it going once, going twice. We'll shut down the web, this YouTube Hangout. Hate saying goodbye. Anybody? Again, I'll put this up here. I'll put it even in bold. Just email me here. Oh, kind of get the idea. quantlabsnet@gmail.com. Just give me a going once, going twice, going three times, otherwise we'll shut her down. We'll be doing another webinar next week. I'll make some advances on my Simulink models. We'll see. Okay, so let's do it going once. Just email me here if you got any questions or comments. Going once, going twice. Going 3 times? No, going 3.5 times. 3 3/4. Okay, I guess we are done. Nothing? Maybe I should wait, just in case an email may have come in. I guess not. All right, if you got any questions, you can just reach out to me on Meetup, Facebook. You can even email me here if you want, but hopefully the spam box won't be able to capture this on YouTube. So far, so good. All right, so I'll do it going once, going twice, going 3 times. Going once, going twice, going 3 times. Okay, I guess we're kind of done. Hopefully you've enjoyed this. Thanks again for hanging out in my hangout. And hopefully I'll talk to you soon or hear from you soon. Other than that, arrivederci, and we'll talk to you later. Oh, and this video will be up as soon as I press the stop broadcast button. Other than that, I'll talk to you guys later. Thanks again. Bye.